Good day everyone, this is teacher Angelica Maymaka, your teacher for today. So the discussion is all about optimization problem, which is part of the grade 11 senior high school curriculum, specifically in STEM strand, which is science, technology, engineering, and mathematics. So the competencies being addressed in this lesson are solve optimization problems, compute higher order derivatives of functions. So, let's start. When we say optimization problem, it is maximizing or minimizing some function relative to some set, often representing a range of plots available in a certain situation. The function allows comparison of the different choices for determining which might be the best. So, the common application of optimization are minimal cost, maximal profit, minimal error, optimal design, optimal management, variational principles. So, next, lilipat naman tayo sa optimization problem, which is absolute extrema. So, here is the procedure for finding absolute extrema. Meron tayong before that, i-explain muna natin kung ano nga ba ang absolute extrema. So, pag sinabi natin absolute extrema, nothing more than the largest and the smallest values. So, tulad ng sabi ko kanina, meron tayong procedure na kailangan sundin. Yung una, verify the function is continuous on the interval a and b. Find all critical points of f of x that are interval a and b. Second, evaluate the function at the critical points found in the step 1 at the endpoints. And lastly, identify the absolute extrema. So there really isn't a whole lot to this procedure. We call the first step in the process step 0, mostly because of all the functions that we're going to look at here are going to be continuous. But it's something that we don't need to be careful with. This process will only work if we have function that is continuous on the given interval. The most labor-intensive step of this process is the second step, which is the step 1, where we find the critical points. It's also important to note that all we want are the critical points that are in the interval. So let's do some examples presented in your screen. So, una dito is we would like to determine the absolute extrema for the following function and interval. G with respect to t is equal to 2t cubed plus 3t squared minus 12t plus 4 on interval -4, 2. So all we really need to do here is follow the procedure given a while ago. So first, notice that this is a polynomial and so is continuous everywhere and therefore is continuous on the given interval. Now, we need to get the derivative so that we can find the to find the critical points of the function. So, we will get the derivative of g prime t is equal to, so ang magiging derivative na ng given ay g prime t is equal to 6t squared plus 6t plus 6 plus minus 12 is equal to 6 multiplied by t plus 2, quantity t minus 1. It looks like we'll have two critical points here. Ano yung mga yon? Ito yung t is equal to -2 and t is equal to 1. Note that we actually want something more than just the critical points. We only want the critical points of the function that lie in the interval in question. Both of these do fall in the interval, so we will use both of them. They may seem like a silly thing to mention at this point, but it is often forgotten sometimes by the students, usually when it becomes important, and so we will mention it at every opportunity to make sure it's not forgotten. Now, we will evaluate the function at the critical points and at the end points of the interval. So, ang makukuha natin doon ay g, the value of the function g with x is equal to negative 2 is equal to 24. The value of the function g with x equal to negative 4 is equal to negative 28. The value of the function g with x equal to 1 is equal to negative 3. The value of the function g with x equal to 2 is equal to 8. Absolute extrema are the largest and smallest the function will ever be, and this 4 represents the only places in the interval where the absolute extrema can occur. So, from this list na present yung 4, we see that the absolute maximum of g, the function gt, is 24, and it occurs at t is equal to negative 2, our critical point. And the absolute minimum of g with respect to t is negative 28, which occurs at t is equal to negative 4. Yun naman na yung magiging endpoint. So, in this example, yung example number 1 natin, nakita natin na ang absolute extrema can and will occur at the both endpoints and critical points. One of the biggest mistakes of the students, kayong mga students, pag nagsasolve ng absolute extrema, nakakalimutan nilang i-check yung endpoints of the interval. So, wag na wag niyong kakalimutan yung students. So, next example naman natin is determine the absolute extrema for the following function and interval. Ang given naman natin is the function gt is equal to 3. Same lang kanina, pero magkaiba lang ng interval. Ang naging interval naman ngayon is 0, 2. On 0, 2. So, una, hanapin natin yung critical points. Note that the problem is almost identical to the first problem. The only difference is the interval that we're working on. So, the first step is to gain the critical points. From the first example, we know these are t is equal to negative 2 and t is equal to 1. At this point, it's important to recall that we only want the critical points that actually fall in the interval in question. This means that we only want t is equal to 1 since t is equal to negative 2 falls under interval. Now, evaluate the function at the single critical point in the interval and the two endpoints. So, the value of the function g with x is equal to 1 is equal to negative 3. And the value of the function g with x equal to 0 is equal to 4. And the value of the function g with x equal to 2 is equal to 8. From this list of the values, we see that the absolute extrema maximum is 8 and will occur at t is equal to 2. And the absolute minimum is negative 3 which occurs at t is equal to t is equal to positive 1. As we saw this example, a simple change in the interval can completely change the answer. It also has shown us that we do need to be careful to exclude critical points that aren't in the interval. Had we forgotten this and included t is equal to negative 2, we would have forgotten the wrong absolute maximum. We will proceed to example number 3. Ang ating example number 3 is to determine the absolute extrema for the following function and interval with the given the function qy is equal to 3y multiplied by the quantity y plus 4 raised to 2/3 on the interval negative 5 and negative 1. Again, as with all the other examples na sinolve natin kanina, this function is continuous on the given interval, and so we know that this can be done. First, we will need to derive or get the derivative and make sure that you can do simplification that we did here to make the work for finding the critical point easier. So, yun. So, ang derivative ng ating given ay 3 multiplied by the quantity y plus 4 raised to 2/3 plus 3y multiplied by the quantity 2/3 multiplied by 1 plus 4 quantity y plus 4 raised to negative 1/3. By doing the simplification, simplify na natin. Magiging 3 multiplied by the quantity y plus 4 raised to 2/3 plus 2y all over the quantity y plus 4 raised to 1/3. Next, and simplify natin ulit. Magkakaroon tayo ng 3 multiplied by 1 y plus 4 plus 2y all over the quantity y plus 4 raised to 1/3. And simplify natin ulit. Magiging 5y plus 12 all over the quantity y plus 4 raised to 1/3. Then, magkakaroon na tayo ng 2 critical points dun sa na-solve natin. Ang critical points na una is y is equal to negative 4. Bakit y is equal to negative 4? Because the derivative doesn't exist here. And next, y is equal to negative 12 over 5 because the derivative of 0 is here in the given. The critical point y is equal to negative 12 over 15. So both of these are the interval. So let's evaluate the function at these points, at the end points of the interval. So magkakaroon tayo the value of the function q with x equal to negative 4 is equal to 0. And next, the value of the function q with x equal to negative 5 is equal to 15. And the value of the function q with x equal to negative 12 over 5 is equal to negative 9.849. And lastly, the value of the function q with x equal to negative 1 is equal to negative 6.241. So the function has an absolute maximum of 0 at y is equal to negative 4, and the function will have absolute minimum of negative 15 at y is equal to negative 5. And if we had ignored or forgotten about the critical point where the derivative doesn't exist in y is equal to negative 4, we would not have gotten the correct answer. So, kasi pag may nakakalimutan tayo or may na-miss tayong isang solusyon, ibig sabihin, asahan mo na magkakaroon ka na ng maling sagot. So, be careful and do the step-by-step process ng pagsosolve. So, next, we are going to look at optimization problems. And in optimization problems, we are looking for the largest or the smallest value that function can take. We saw how to solve one kind of optimization problem in absolute extrema, yung sinolve natin kanina, where we found the largest and smallest value that a function will take on interval. So, ngayon, sa optimization problem, meron tayong steps na kailangan sundin. The first step in all of these problems should be to very carefully read the problem. Analyze mo siya na mabuti. Dapat alam mo kung ano yung tinatanong. Ganon. And next, and once you have done that, ang next step naman is to identify the quantity to be optimized and the constraint. Identifying the constraint. And in identifying the constraint, remember that constraint is the quantity that must be true regardless of the solution. So, dapat true lang talaga siya. In almost every one of this problem we'll be looking at here, one quantity will be clearly indicated as a having fixed value and so must be the constraint. Once you've got identified the quantity to be optimized, should be fairly simply to get. It is, however, easy to confuse the two if you just skim the problem, so make sure you carefully read problem first. So let's start solving optimization problem by this example. We need to enclose a rectangular field with a fence. We have 500 feet of fencing material and the building is on one side of the field. And so, won't need any fencing. Determine the dimensions of the field that will enclose the largest area. So, paano to? In all of these problems, we will have two functions. The first is the function that we're actually trying to optimize, and the second is the constraint. So, una natin gagawin, kailangan muna natin i-sketch yung situation dito sa example na to. Kasi matutulungan, ito yung isa sa mga helpful na step 10 sa pag-intindi ng isang worded problem. So, let's do that. Feel free to pause the video para ma-figure nyo or ma-drawing nyo kung ano yung hinihingi dito sa example number 1. And, ito nga. So, ayan na yung magiging graph. Figure ng ating illustration. Ay, ng ating example. So, in this problem, we want to maximize the area of the field. We know that we use 500 feet of fencing material. So, the area will be function we are trying to optimize, and the amount of fencing is the constraint. The two equations that we're going to use and for this are the maximize is A is equal to xy, and the constraint will be 500 is equal to x plus 2y. And now, we know how to find the largest or the smallest value of the function provided it's only got a single variable. So, the area function as well as the constraint has two variables in it. And so, what we know about finding absolute extrema won't work. So, hindi mag-work yung method na ginamit natin kanina. However, if we solve the constraint for one of the two variables, we can substitute this into the area, and we will have a function of a single variable. So, let's start solving the constraint for x. So, x is equal now to 500 minus 2y. So, let's start by getting the derivative and find the critical points. So, ang ating derivative is a derivative of y is equal to 500 minus 4y. So, setting this equal to 0 and solving gives alone a critical point of y is equal to 125. Plugging this into the area gives an area of a, the value of the function a with x equal to 125 is equal to 31,250 feet squared. So, according to the method from absolute extrema, this must be the largest possible area since the area at either endpoint is 0. Fine. So, finally, let's not forget to get the value of x. And then we'll have the dimensions since this is what the problem is asking for. We can get the x by plugging in our y into the constraint. So, x now is equal to 500 minus 4y. X now is equal to 500 minus 2 multiplied by 125. We'll get the value of x is equal to 250. So, the dimensions of the field that will give the largest area, subject to the fact that we use exactly 500 feet of the fencing material, are 250 times 125. So, don't forget to actually read the problem and give the answer that was asked for. This type of problems can take a fair amount of time and effort to solve, and it's not hard to sometimes forget what the problem was actually asking for. So, plan, after reading the problem, kailangan isipin mo na or iplano mo na kung ano yung mga gagawin mong steps sa pag-solve ng problem na yon. So, before proceeding with any more examples, let's spend a little time to discuss some methods na gagamitin natin in solving optimization problem. Una dito, yung use the method used in finding absolute extrema. Next, yung use a variant of the first derivative test. And the last method is use the second derivative. Okay? First, discuss muna natin kung ano yung use the method used in finding absolute extrema. So, this is the method used in the first example kanina. So, the two main issues that will often provide this method from being used is we'll actually have a range of possible solutions that have finite endpoints at both ends. We'll see at least one example of this as we work through the remaining examples mamaya. Pagsasolve natin mamaya. Also, many of the functions will be optimizing will not be continuous once we reduce them down to a single variable, and this will prevent us from using this method. So, next. Okay. The explanation presented in your screen is the summary kung paano natin gagamitin yung method na first derivative test. So, paano nga ba? If the first derivative of x is greater than for all x less than c, and if the first derivative of x less than 0 for all x greater than c, then the function fc will be the absolute maximum value of f of x on the interval I. And next, if the first derivative of x, f of x, less than 0 for all x less than c, and if the first derivative of x for f of x greater than 0 for all x greater than c, then the function fc will be the absolute minimum value of f of the function x on the interval I. Next naman tayo sa method 3, which is using the second derivative. Dito naman, if the second derivative of f of x is greater than for all x in I, then the function fc will be the absolute minimum value of the function fx on the interval I. And second, if the second derivative of function x greater than 0 for all less than 0 for all x in I, then the function fc will be the absolute maximum value of f of x on the interval I. So as we work some examples, we will use these methods na binanggit natin. So in some cases, the method we use will be the only method we could use. In others, it will be the easiest method to use, and in others, it will simply be the method we choose to use for that example. It is important to realize that we won't be able to use each of the methods for every example. Kasi meron lang talaga tayong specific method na magagamit dun sa problem na yon. So let's work some more examples. So let's try this example. A printer need to make a poster that will have a total area of 200 inches squared and will have 1 inch margin on the sides, a 2-inch margin on the top, and 1.5-inch margin on the bottom, as shown below. What dimension will give the largest printed area? So, this problem is a little different from the previous problems. Both the constraint and the function we are going to optimize are areas. The constraint is all about overall area of the poster must be 200 inches squared, while we want to optimize the printed area. An example is the area of the poster with the margin taken out. So let's define the height of the poster to be h and the width of the poster to be w. Here's a new sketch of the poster, and we can see that once we've taken the margin into account, the width of the printed area is w-2, and the height of the printer is h is equal h negative 3.5. So ayan yung figure ng ating example number 3. So the equations that we'll be working with is maximize a is equal to the quantity w minus 2 and the quantity h minus 3.5, and the constraint will be 200 is equal to wh. So first, we need to solve the constraint. Solving the constraint for h and plugging into the equation for the printed area gives us the function aw is equal to the quantity w minus 2 multiplied by 200 over w minus 3.5. Simplified na natin. So, magkukuha tayo ng 207 minus 3.5w minus 400 over w. So, the first and the second derivatives ng ating given ay first derivative of aw is equal to negative 3.5 plus 400 all over w squared. And then simplify, magiging 400 minus 3.5 w squared all over w. And ang second nating derivative is negative 800 all over w cube. So, from the first derivative, we have the following two critical points. W equal to 0 is not a critical point because the area of the function does not exist here. So, ang ating critical point is equal to W positive negative the square root of 400 over 3.5. And now, it is equal to positive negative, pag na-simplify na, magiging sagot ay positive and negative 10.6904. However, since we are dealing with the dimensions of a piece of paper, we know that we must have W is greater than 0. And so, only 10.6904 will make sense. And also notice that provided W is greater than 0, the second derivative will always be negative. And so, in the range of possible optimal values of the width, the area of the function is always concave down. And so, we know that the maximum printed area will be at W is equal to 10.6904 inches. The height of the paper that gives the maximum printed area is then H is equal to 200 divided by 10.6904. Simplify natin, ang magiging H na is 18.7084 inches. And now, itong slide na to is your assignment or sit work. So, ang gagawin nyo, kailangan yung i-determine kung anong method yung kailangan, yung i-determine nyo yung constraint, kailangan yung i-optimize. So, dapat i-follow nyo yung step para hindi kayo malito. And, as much as possible, draw or illustrate nyo yung, make an illustration ng mismong problem para hindi kayo mahirapan at mas madalian kayong intindihin kung ano yung problem na yon. So, thank you for listening. Thank you for listening.